everyone. Matt DiNapoli here. I'm a manager of developer advocacy with the Cisco Developer Relations Program.
Hey, Snackers. This is Kareem Iskander. I'm a lead technical advocate with Cisco Learning and Certifications.
And welcome to episode 77 of Snack Minutes. Snack Minutes is your weekly 10-minute bite of learning covering tech, coding, and some cool projects that we work on.
And the cool thing that we're going to talk to you about today is VPC on AWS with our guest, Dewan Lightfoot. Dewan, do you mind introducing yourself?
Hey, what's up, Kareem? Hey, Matt. Thank you for having me on. My name is Dewan Lightfoot. I am a developer advocate here at AWS, formerly Cisco DevNet developer advocate. I'm excited to talk to you all about VPC today.
We're excited to have you, Dewan. Dewan, for everyone that is either new here or hasn't been here, is our first external guest. Everyone that we've talked to previously has been a person from Cisco. So, Dewan, we're really excited to have you back in the fold a little bit, but representing AWS today. And we're excited to hear about VPCs and how we can take advantage of them for our development projects and our applications.
Awesome. Thank you.
So, Dewan, start us off. What are VPCs for those who are wondering?
Okay, so the Amazon Virtual Private Cloud, or VPC, enables you to spin up your resources in a virtual network that you define. Now, it's similar to your traditional network that you have in your traditional data centers, but the difference is that you have the ability to scale on the AWS global infrastructure.
So that's exciting because now we can scale or downsize depending on our needs for our application deployments. And it sounds like globally rather than being kind of tied to whatever network infrastructure we have managed in our own data centers.
Correct. Currently, we have about 27 regions in AWS that's spread all across the world. In those regions, we have about 87 availability zones. So to kind of break it down for you, you have your regions, which are geographically separated. And then you have availability zones, which are data centers that may be separated about 50 to 60 miles apart, kind of keeping you safe from those natural disasters like flooding or earthquakes and et cetera. So if you're spinning up EC2 instances, you can define them and you can select your region, select your availability zone, create a VPC, and then define a CIDR block for that VPC, and along with your subnets, and then from there, spin up your EC2 instances or whatever applications that you want to build on AWS.
So if you come from the networking world, at the end of the day, VPCs are basic network, right? So your networking knowledge, whether you leverage it on your device on-prem or you leverage it in an instance like AWS, it's the same. You gotta go build your network, assign IPs, get your netmask going. So I'm assuming you're gonna show us how easy it is to set up a VPC in AWS, Dewan?
Correct. There's so many similarities. Now, there are some differences that you'll learn as you get comfortable with AWS, but that traditional fundamental networking knowledge still applies in many areas of AWS. If you don't mind, I will spin up VPC right now.
Sure, let's see it.
So the first thing we need to do is have an AWS account. And once you create an AWS account, you log into the AWS console. And then from here, you have your search window where you can type VPC, and then we'll select VPC. Now, when you initially log to AWS, everyone gets a default VPC. And so what is that default VPC? Let's say you're someone that's brand new to AWS, and you just want to get started with EC2, spinning up a virtual machine. Well, that default VPC is going to have everything you need to create your EC2 instance or your Elastic Compute Cloud instance. And then from there, what you can do, or Cloud Compute instance, what you can do is connect directly to the internet once you launch it into that VPC. So what's in a default VPC? You have the actual VPC, you have your subnets that are already created, you have your route tables, as well as your internet gateway that you need for connectivity to the internet. And we'll kind of walk through this when we create our sample VPC. One other thing that I want to point out and mention is that currently we're in the Northern Virginia region, or US East 1. I mentioned that we have 27 regions across the globe, and they are all here. So wherever you want to, your customer lives around the globe, you select that region so you can be as close as possible to your customer.
Interestingly enough, there's one in Ohio, where I'm from, and one in Northern California, where Kareem's from.
Correct.
So we should have no complaints.
Correct.
And Dewan, just a quick question: when you first create that VPC, is that VPC considered private or public?
Okay, so let's talk about that. You actually define what you want to have access to your VPC, and we can kind of go from there. So when we talk about a VPC, inherently it's secure. If you just create a VPC by itself, it's going to be isolated and nothing can talk to it unless you tell it to talk to that network or that EC2 instance. And you kind of define that with your network access control list, or NACLs. This is going to be the subnet boundary for your VPC, right? And
NACLs.
The thing about the NACLs, yes, NACLs. The thing about
You're
the NACLs is that
You're NACL.
the thing about NACLs is that they are a stateless firewall. So what does that mean? That means if you allow traffic in one direction, you also have to allow the return traffic as well, right? And so if you need something more granular, and I haven't talked about this yet, but whenever you spin up an EC2 instance or you start deploying things inside of your VPC, they're going to have what you call an ENI, or an elastic network interface. And so this is how IP addresses and devices communicate within your VPC. Now, when I talk about getting more granular on the security, you can actually use security groups to define what can talk to what through those ENIs, right? What ENIs communicate to which ENIs inside of your VPC or inside of your subnet. So you have your NACLs, which are the subnet boundary, and then you have the more granular, which is related to the ENIs, the actual interfaces of your EC2 instance in security groups. Now that we're in the VPC console, let's go ahead and create a VPC so we can kind of walk through and show you how easy this is to get started. Under VPC dashboard, which is on the left navigation pane, we'll click Create VPC. And now from here, we have an option to just create a VPC or to create a VPC with more resources that we need. Now, I'm going to go ahead and use the auto-generate function, and we're going to call this, let's call this Cisco. So we'll tag every resource that we create within our VPC for our VPC with the Cisco tag. I mentioned the solder block that's defined. Here we'll do a /16 for our solder block, which gives us roughly 65,000 IP addresses that we can actually use within our VPC. Now, 5 of those will be served. That's something we'll talk about as well.
I feel like Amazon calculates the number of IP addresses on a /16, which is like half of the part of your CCNA certification on how to calculate that. So it's like, it's there for you. You don't even need to know it anymore.
Well, now I know that's off the top of my head, 65,536, I think, was the right number, right?
Hey, this is Snack Minutes. This is all about automation. It's automated for you.
Yeah, exactly.
You do have the option to bring your own IP addresses, but in this instance, we're going to go ahead and use the private subnet range of the 10./16. If we wanted to, we could also use the IPv6 solder block, and you can also bring your own IPv6 solder range as well for IPv6. Now here we have the option for a tenancy. Let's say you want to have your EC2 instances spun up on dedicated hardware, and it may be some applications that need to be directly connected. So you could actually set this to dedicated tenancy. But for this demo, we'll just do default. Now, I mentioned the availability zones. For resiliency and high availability, we're going to use 2 availability zones. That way, if something happens in one location, you'll have another location that either is always up and active or passive active, depending on how you want to run your network. And then here's the option for our subnets. Now we could do 0 public subnets and have 2 private subnets. The difference between the public and private subnets is that the public subnets have a route to an internet gateway, which is how you access the internet. And the private subnets do not have access to the internet. Now, they can have access to the internet through a NAT gateway. And we'll talk about the differences between the two here in a moment. So now we have two public subnets, two private subnets. We have the ability to customize our solder blocks. Here we'll do a /20, which provides about 4,000 IP addresses for each subnet. And then if we wanted to give internet access for our private subnets, we can use a NAT gateway. Now, the difference between an internet gateway and a NAT gateway is that the internet gateway allows you to connect to those devices inside of the VPC. So you get a public IP address, you can access or SSH into an instance or connect to that web page through that internet gateway. A NAT gateway, let's say you got a database that you want to keep private, but you need to upgrade that database. You go through the NAT gateway to access the internet, but you don't allow any traffic to those addresses. They don't get an IP address, right? They don't get a public IP address. So we'll say none. And then lastly, we have the option here for VPC endpoints. Now, things like S3 and CloudWatch, they actually have public address spacing. And so in order to access those, you got to go through an IGW to access Amazon S3 since it has a public IP address. Well, you may not want that. You may have just a private subnet that you don't want to have access to internet. What you could do is create a VPC endpoint, specifically S3 endpoint, that allow you that private connection that you want without traversing the internet. And then lastly, we have our DNS options. And this allows us to have DNS resolution within our VPC, as well as over the public internet if we have something like a web server that was spinning up and we want that to be accessed publicly.
Ooh, they thought of everything, didn't they? Kareem.
They really did.
Now, before I click create, one good thing that I like is this preview. You can kind of see all of your dependencies and track them throughout to see what's actually getting created. So notice that we have our VPC, and then we have our public subnet. And notice that the public subnet is attached to a public route table. And notice that it has a route to the IGW or the internet gateway.
Now, I have a question for you, Duan. As we're talking about this, right? I think one of the things that anybody that deploys anything in any cloud is cost, right? And so is there like if I were to do a private subnet versus a public subnet, is that my cost is going to be reduced? And if I'm not sure if you know, or is it just a fixed price based on usage?
So there is inherent cost if you're using an internet gateway. And so if you use the AWS pricing calculator, you can kind of determine what that cost is. Now, but what we're doing right now, there is no cost for what we're spending up right now, because there's no cost for the Amazon VPC itself. Now, once you start using an EC2 instance, there's a cost for depending on that. So, but I'll give you a link to the AWS pricing calculator as well as some getting started links, and then you all can check it out from there.
Yeah, I think all snackers that are watching this should go out there and get a free account just to test out what Duan walked us through. I know I will.
Yeah, I mean, but Kareem, to Duan's point, the VPC itself is useless unless we're actually doing something within it, and that's where they get their money, right?
For sure. But there's also, like, I think some services out there will charge you for having a public IP address, right?
I gotcha. Yeah.
Now, if you have questions about cost, I mentioned the AWS pricing calculator. There's also services that are in the AWS free tier. So there's actually an EC2 instance that you can spin up and operate that's in the free tier. So if you want to get started with AWS, we do have resources and services that are available for you to get started, and they're at no cost, depending on how you use them. So I would definitely use the AWS pricing calculator to ensure what you're using, you won't be charged for it. But, that's part of learning the cloud to get understood, the solutions that you're going to be implementing. Now, what we're doing in the console, but remember, we do have things like the Python CDK, the Amazon CDK. We do also have CloudFormation. You can use Terraform. There's many different tools that you can use to automate this process, because Right now, we're building out one VPC. What if you had to build out 100 VPCs? At that point, you're really going to leverage some type of automated tool.
Yeah, that was going to be my next comment. Maybe we should have Dewan back and show us how to do this in Python, show us how to do this in Terraform, show us how to.
I was going to say, Terraform does a great job, deploying it. And the one of the best providers I played with, and that's really well written, is the AWS Terraform provider.
Yeah.
It's pretty cool.
And then you can tie it to other services. I mean, because we are on a Cisco show, we can tie it to other services that Cisco provides, and pop that into your VPC and make that all part of your Terraform deployment.
Well, I think the other thing is, like, if you're looking at expanding your private or on-prem cloud to your public cloud, right? Mm-hmm. This is where all of this comes in play. You're going to have to set up everything here that we talked about, bring in SD-WAN into the mix, and then connect the two sites essentially, so you can have one public cloud, one cloud.
Right, and then of most importance is understanding those NACLs so that they can talk to each other. Dewan, unfortunately, unless you have anything to wrap up, we're running short on time. You've already been a guest on the show, so we're not going to ask him the superhero question.
No, but I do have to say something to our snackers, that if you're looking at this and wondering, all of these terms, what are we talking about? This is not just for AWS. This is, like we said in the beginning of the show, this is your basic networking. So if you're wondering and you're interested, one of the things that I would suggest you look at is, our CCNA training, as well as our Cisco CCNA certification, because that essentially would help you tremendously with all of this.
Yeah, it can definitely tie in all of the necessary foundational knowledge that Dewan is building on.
Right.
Dewan being, I believe you're a CCNP, aren't you, Dewan? That allows you to understand why VPCs are necessary and how to build them out for your internal networks.
Yeah, and if I could make one point, is that we're talking about the cloud here, but a lot of network engineers and network developers, they're operating on premises as well. So understanding things like VPN and connectivity between the two, that's something maybe we can talk about in another session. But really understanding VPNs and how they work and how to connect to the cloud is the next piece of the puzzle that you're going to have to understand as well.
Snackers, thanks for being here, and thanks for watching this episode of Snack Minute. Join us next time, where we have another fun topic to talk about.